The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
You made it. We haven't even started yet. All right, I'm going to get going. Hi, everyone. Thank you. Welcome. We're here to talk about my NixOS-Powered Homelab. My name's Josh Lee. First, a little bit about myself. So I am a developer advocate or an open source advocate at Altinity. We offer hosting and support for ClickHouse, which is an open source database that has nothing to do with any of this, but we do use Nix a lot in our development process, and I just love it. So it's something that I had been using in my home lab since before I joined Altinity. And we're going to talk about that. And then my lawyers made me put this here, but basically Altinity is a registered trademark of Altinity. ClickHouse is a registered trademark of ClickHouse, and we're not affiliated with ClickHouse at all, but we are open source contributors and we love the project. And that's enough about that. So let's talk about NixOS. How did I get to NixOS? So first, by show of hands, anybody already running Nix in some form or another? Okay, that's good. All right, can one of you volunteer like a definition of like what Nix is? Brave soul, and I'll repeat it through the microphone. An immutable OS that's built by a declarative structure. Yeah, that's a good start. For NixOS, yes, that's true. And then there's also Nix, right? The thing underneath NixOS, which is a language and a package manager and kind of a GitHub repository and a bunch of tools and stuff that goes around that, right? So there's a lot of stuff here. We're going to talk about the bits and pieces that I'm using in my home lab, but there's a lot of other stuff too, right? So like might be the first way, for those of you not familiar with Nix, this might be the first way that you interact with Nix, right? You would install it, and then you would run a command like this. And basically what this command says is, give me a shell that has the ClickHouse binary available on the path. And Nix has instructions, it has recipes for pretty much everything under the sun that's open source, right? It has recipes for how to build that. And it also has a cache that I can download those built artifacts from if I trust someone else to build them for me. But if I want to build them myself, I can. And then I have a shell that has that binary available. And then as soon as I exit out of that shell, that binary was stored in an immutable path. That means that I can run a garbage collection process and it sees, oh, there's nothing linking to this binary anymore. I can just delete it. And that's goodbye ClickHouse, I don't have it anymore. And so this is really great for just like, I really quickly want to try something out, or like there's some tutorial that says I need something and I just need to install it really quickly. And then I don't want to remember how to uninstall it or that I installed it. I just want it to go away once I stop using it. Awesome use case of Nix. Some of you have probably heard of Home Manager. Anyone using Home Manager by show of hands? Brave souls. I'm also using it. I love it. Home Manager is great if you have like lots of different operating systems that you use, and it basically gives you everything that Nix gives you for NixOS for your entire operating system. Home Manager does it just for your dot files. So it's a great way to keep your configurations the same, since I use on a daily basis a Mac and like 6 different flavors of Linux. It's awesome to just always have the same dot files. And then Flakes is another thing that we're not going to talk about. And if Flakes scare you, and if you see too much about Flakes when you're reading about Nix, just know that you don't need them. And actually, they're not that complicated. Really, all they do is like an NPM lock that pins your inputs. So they're kind of scary, but they shouldn't be scary. But anyways, those are all different ways that would be sort of normal to jump into Nix and the Nix world. But it's not how I started. I started with a different problem. I had a home lab with a bunch of Debian flavored VMs and using Proxmox, right? And I have all of these multi-gigabyte templates. Every time I want to do something or save something or like roll back something, I have these really, really massive files that I'm having to store and copy and transfer over my very slow network and on Raspberry Pis and stuff. It's like, this is kind of a pain. So like, how could I make my templates? I come from a developer background, not an infrastructure background. So I like code. I wanted to define everything in code and have that be the only thing that I saved. Wouldn't that be nice? And then another issue that I kept running into is like some of my VMs would share parameters. For example, my VM that's running my monitoring stack, the Prometheus scrapers need to be configured based on the exporters in all of my other VMs. That's a very basic example, right? But it's an example where you need to take a piece of information from one VM's configuration and use it in the configuration of another VM. That comes up quite often. And then finally, right, like I'm applying and deploying these images using Proxmox ClickOps and sometimes CLI commands and sometimes Ansible commands. Ansible's awesome. I love Ansible, still use it every day, but it didn't do a lot for me in terms of like keeping track of what I had put where and what commands I had run where, what I had upgraded, right? So I didn't really have an easy way to just look at what I had going on. I had to go look at each individual server or set up some kind of observability stack. Observability is awesome. You should also do that too. But it's really nice to be able to just look at your code and see what's going on or what should be going on. So that's kind of how I came into NixOS, right? People have been telling me about this Nix thing as this replacement for ASDF or other like package managers for development environments. And while it is really, really useful for that, I found this blog post that was completely incomplete about like how to use Nix to build VMs and deploy them to Proxmox. And I'm like, oh, maybe this is everything that I needed. And of course, that blog post was incomplete. The Nix documentation is, shall we say, fun. And this was the beginning of a very, very, very deep rabbit hole, but it was worth it in the end. So why did I end up choosing NixOS and sticking with it? I've been running it. We'll see at the end of this. I've been running it for almost 2 years on some of my VMs. It's GitOps-ish, right? I'm going to show you some examples of the code, but basically everything, all the configuration is defined in a single code file for your whole operating system configuration, services running on that operating system, everything in one big tree. It's awesome. That makes it kind of self-documenting, right? I can see what I have committed, and I know that as long as I applied those configurations, that's what's actually running on my server. Because of the way that the Nix package manager works, those configurations are extremely portable and reproducible, right? I can make sure that they're exactly the same anytime that I build them. I know that I'm going to get the same VM anytime that I spin it up, and I can move it from place to place or build it for different architectures. It's awesome. And then under the hood, NixOS, for me, was doing a lot of things that were already familiar. Systemd, Docker, these were tools that I was already used to using every day. So there was only one additional abstraction layer that I had to learn, not a lot more. So that was nice for me. This is kind of what a configuration file looks like, right? So this is a template in my templates directory, right, that I use for all of my servers. There's not a lot going on here, right? This looks like a pretty simple, straightforward file. And this is kind of what I love about Nix, the language. And we're going to talk about it in a little bit, but like the NixOS module system lets me do this. So every configuration is a module. A module is just a function. This function, you're going to see ellipses in my other screenshots that are actually like I left something out, but in this case, the ellipses is actually part of the code. And I'm just saying, I don't care about the arguments. I don't need any of them. I'm defining some imports. That base import template is the one that we're really going to dive into everything that's inside of that in this talk and how I set up my NixOS configuration specifically to run as a VM guest. So there's a lot of interesting stuff going on in there. And then I have an example user, right? You can import whatever else you want, but imports isn't really the main way that you change things in NixOS. The main way that you do it is with configurations. And so here I've changed my configuration to just use volatile storage for my logs for all of my servers, because I'm also shipping the logs off to Loki and I don't care about keeping them on the disk. And Proxmox having 12 VMs running off of a single NVMe is going to kind of thrash that NVMe. So this is nice, right? But what's really nice about this is like, I can be as expressive as I want to be. I don't have to put the whole configuration here. I can keep some of it in those includes, and I can even override some of the parts that I want to, right? So I can and then because I'm using this one language for configuring all of the things within the operating system and all of the things running in the operating system, right? It means I have this one object tree where if there's anything that's a variable or a parameter that I need to pass from one part of that object tree to another, because those things should always be the same, it's just all there, right? So this is pretty powerful. And why Nix the language? So Nix the language, I don't know the full history of it, right? But it's pretty much the only time you're going to come across it is with Nix the package manager in NixOS. But I do like this shared object tree. I love that it's functional. My my brain seems to work better with functional things than object-oriented things. And the Nix module system is the best part for me, right? Like one of the very, very first programming adjacent things that I did was CSS. And while we might all have our complaints about CSS, I think like the way that you can have like specificity and override things is really, really cool. And Nix modules lets us do that. And it lets us have like it lets us co-locate the code for a task rather than co-locating the code because of what type of code or what language or what technology it is, right? So we can say all of the things for running Pi-hole, right, go here, whether it's low-level system config or the actual configuration that's passed into the container. All right, so let's talk about actual VMs. So NixOS generators, I said there's this whole ecosystem of tools around Nix and NixOS. This is one of them. So NixOS generators is a package that you can install with Nix. If you have Nix, you can just do nix shell-p NixOS generators, and then you'll be able to run this command. This command, I'm passing in a configuration.nix file. That's going to be similar to what you would, if you're actually running NixOS directly, right? That's a file that lives in etc/NixOS. And here it's just in my local repo, in my code directory, my working directory. And then I can specify a format. There's a ton of formats, right? Proxmox is the one I use, but there are a bunch of others. You can look them up in the documentation for the NixOS generators. And then what this command does is instead of reconfiguring my local machine, it creates a VMA, in this case, a VMA image. It depends on the format, right? But a VMA image is what Proxmox uses as a backup. And then I can just upload that file to my Proxmox server by any mechanism, right? Ansible, SCP, whatever. And then I can deploy VMs using that base image that are going to have all of this configuration from first boot. You can do cloud init, right? But like with this, I don't even need cloud init because I can just say, this is what you're going to be. This is what your IP address is going to be. These are the SSH keys. So this is really powerful for getting those base images. And this, for me, solved that initial problem, right? Of like, I have all of these these large multi-gigabyte templated base images. Well, no, now I just have a bunch of configuration.nix files, and I can build base images from those whenever I need them. That's pretty cool. So let's look at what's inside that configuration.nix file, right? What makes this actually work? What makes NixOS play nice as a guest? Well, to start, this is the beginning of my file, right? I have an import, and I'm importing this special variable modules path, which is one of those arguments that you can accept in your module definition. That's part of the NixOS module system. And what that path actually points to is a location inside the Nix packages repository, which is on GitHub, right? And then you can go through that repository. There's the modules folder, the profiles folder, and then inside that folder, there's actually going to be a bunch of different files for different types of hardware and environments that you might be running NixOS in. There's one for LXCs, there's one for building container images, which I think someone is giving a talk about tomorrow. And yeah, so there's just a bunch of stuff in there that you can use as your starting point. And this has like a lot of your hardware configuration that you might need that you would get from the installer if you were installing NixOS directly onto bare metal hardware. In this case, we're running in Proxmox. Proxmox uses QEMU as its hypervisor underlying technology, right? So we've got this profile that's provided for us, QEMU guest. Very nice. This provides a bunch of handy things for us. And then we also can enable the QEMU guest service. This is nice. This then enables the service that allows Proxmox to talk to the guest and say, hey, you need to shut down, you need to restart, gets things like the IP address and all that nice information. So this is all that's needed to have a VM play nice in, Proxmox. Then, all right, Nix has this other really cool thing that I haven't mentioned yet. Nix has a bootloader that lets you reload any previous configuration. So anytime you change your system configuration, you get a new generation in your bootloader. And then say you screw everything up or you change something and it didn't work the way that you wanted it to, you just reboot and you're presented with all of your previous generations and you can just roll back like that. So built-in rollbacks, built-in rollbacks is great. You can use Grub for it. You can use other bootloaders, but I just use Grub. And then the second line, I'm saying I don't need this basically tells the configuration. I'm not going to have an EFI device. So just use legacy BIOS and keep the bootloader on the system root disk. So this just makes deploying VMs really easy. This is really important. do not leave this out of your configurations. This tells NixOS on boot up to increase the size of the root partition to match the size of the underlying, or to increase the size of the file system to match the size of the underlying drive, right? This means that if you resize the drive in Proxmox, all you have to do is reboot and NixOS will see all of that additional space. And as much as NixOS is awesome, one of the things that it does tend to do is accumulate cruft, right? You're building all of these packages immutably, and every package gets its own copies of its dependencies if it needs them. And so the Nix store can grow and get large, and you'll run into situations sometimes where like you're running NixOS rebuild switch, and everything just stops because you ran out of disk space because you're like me and you're dumb and you didn't check how much disk space you had left before you started building a really big, heavy build. So to recover from that, make sure this was already on, go to Proxmox, increase your disk size, and reboot. And then run, once you're rebooted and you're in a state where you can actually run commands again, you run nix garbage collect and reclaim that space. Okay, this is kind of the heart of my whole workflow, is remote updates. And I'm going to show the command that actually uses this. But first, we need the VM to be configured to accept it, right? So basically what this says is any admin, anyone in the wheel group, can run the NixOS switch command, which is the command that loads a new configuration. And then I'd also enable some experimental features. So flakes in Nix command, these are considered experimental. Most people are using, I would say like at least half of people using Nix are using these. They're pretty safe to use from a stability point of view. It's really just a philosophical choice if you want to use them or not. But I use them a lot in my configurations, so I have them enabled so that I don't have to worry about if they're enabled on a specific VM or not. By default, they are not enabled unless you use some alternative Nix installers besides the official one. Okay, and then once we've got a VM that has that configuration that allows us to push remotely, right? Then from my local machine, where I have my repo with all of my VM configurations in it, and we can dive into that a little bit. We're gonna have time for some live coding. I can run this command, and I can just say, hey, actually, I'm not building from, there should be a switch or a boot at the end there, right? It should say, because the command is NixOS rebuild switch or boot. Switch changes the configuration immediately. Boot changes the configuration when you reboot the machine. Most of the time you're going to use switch, but especially if you're targeting a remote host and you're changing the networking, use boot so that you don't lose communication with the host while it's still in the process of executing this command. And then it will apply the new configuration, and then you go into the host and reboot it, and you'll get your networking changes. And then use remote sudo. That's just necessary to make sure that we have full access to make all the changes we need to on the remote machine. There's another flag you could add here, which is the build host. I use that all the time, so I have a particularly powerful but power-hungry machine, and when it's on, I like to specify it as the build host, and then my builds happen much faster, and when it's not on, I can build them locally and wait. Oh, one warning about using this command. If you're used to using NixOS as a direct OS, where you're going in and editing configuration.nix and running NixOS switch, or NixOS rebuild switch, then you're used to that configuration.nix file always matching your latest configuration. If you use this NixOS rebuild command, it will not update the configuration.nix on the remote host. So your local repository that you ran the command from is now your source of truth. That has pros and cons. I used to keep all of my machine configurations, including like my laptops and desktops, in one repository. I don't do that anymore. I keep my remote VMs in one repository. And for my actual clients that I use, that's another repository that I keep cloned onto each machine that needs it, and I run these commands locally. Just because it's a real pain when you're like on a workstation and it doesn't have the repo that it needs to update itself. Don't get yourself into that situation. And if you might lose track of a VM, or you might have like a VM or a Raspberry Pi somewhere that like you lost track of the repo that you used to configure it because it's been sitting behind your TV for 3 years, then that might also be a good time to make sure that you're copying that configuration.nix to the target host just for posterity, right? But for GitOps, of course, we want everything to be centralized. We want everything defined in that one repository. That was the goal that we set out with. So for my VMs, this is really, really nice. And then we get into, okay, I said VMs, plural. There's a lot of them. Flakes are kind of annoying. There's some like verbosity to how you set up all of your individual NixOS configurations, and maybe you have a lot of things that you want to import into all of them. So having an individual configuration.nix for each one can be kind of a pain to manage. So here's another code snippet. This is out of my flake.nix, but you can use this without flakes, right? Can everybody read this? Is the text too small? Okay. I saw some shaking heads. I'm sorry. The slides are online, by the way, at this URL, joshwemley.com/events/self2025. So if you want to go grab the slides and look at them on your own device, you can do that. But so what does this do? Okay, so hoster, we're defining a directory. That's where all of my configuration.nix files go, in my NixHost directory, right? And then I'm defining the function read host. I'm defining the function host files. I'm defining the function host definitions. I'm defining the function make system. I'm defining the function systems, right? And all of these functions are using each other and various inputs. All of this Nix kind of looks like a Lisp without the parentheses, right? All of the arguments just use spaces. So like built-ins.map, make system, host definitions. This is the function call. This is the first argument. This is the second argument. Yeah, so what this actually does is it iterates over every .nix file, top-level .nix file in that NixHost directory and builds it as a Nix configuration, which is really nice because then I can just target this and say, build configuration named, and the name matches actually the file because that's what it injected the file name as the host name here, has the flake name. Something I haven't got into a shareable state yet, but that I'm working on is because this has all of my machine configurations in one place, that then solves that problem of being able to take configuration from one machine and use it in the configuration for another machine. Right? I already have one place where I can put all the variables, but I could actually loop over this configurations list and detect things there, right? Like just dynamically detect which exporters are installed so that I can dynamically configure the scrapers. Okay, and then we have these functions lib.makeDefault and lib.makeForce. So lib is another one of those magic things that you can just grab out of your module arguments. You specify lib, and then you have access to lib. It's all the standard library functions. MakeDefault and makeForce, for me, these are the ones that make it work kind of like CSS. So here I have, this is the complete configuration for my ingress that I use for my tailnet, right? And it's importing the server template, which is over here. It's also importing my workload. I've started defining all of my workloads in files because sometimes I want the same workload running on 3 different hosts. And so just defining them inside the hosts stopped making sense. So I have a workloads folder, and that's got all of my ingress routes and everything in it. And I can put that on as many ingress hosts as I want. That's not important. The important part here, right, is I've got networking.hostname equals ingress-L1. And we also have a default networking.hostname defined over here. But I have that lib.makeDefault, right? Which basically just says, if anything else tries to define this, then defer to that other thing. We don't care. And the opposite would be lib.force, and you can pass in numbers, right? So there's like, this gets into kind of like CSS specificity kind of, right? But basically you can just say which things should win out over which other things, which is really nice because it means that your templates can be complete configurations, complete deployable configurations that you can test and then override. Your templates don't have to have these like giant gaps in them where you fill in the details of an actual implementation, which is, for me, is really, really nice. Maybe I spend too much time in Helm, but for me, this is really, really nice. All right, and then per host, the other thing you want to do is, this is a magic configuration variable system.state version. Basically, you're going to set this once when you first configure a host, and then you're probably never going to change it again for the lifetime of that host. Because if you do, a lot of the things that, basically every package that NixOS installs can look at this to determine how its system state should be configured, where it is, that sort of thing, right? So you really just don't want to change this. You want to commit it, and you want to keep it for the lifetime of that host, even as you update to newer versions of NixOS. The state version is going to stay the same. All right, so what about workloads? Oops. So NixOS is, oh, that's really hard to read. Did I make it? Hey, okay, that's a little better, hopefully. So NixOS, one of the really cool things about it is it comes with not just like every package under the sun, but also a ton of really easily configurable services based on those packages. So say you want something like CAdvisor or Grafana or Prometheus or GitLab or yeah, a lot of these things just have a variable, a configuration variable that's just enabled, and you say turn it on, and it will turn it on. And then you can also define your own modules with these configuration options, right? So here, I'm defining a module that I call monitoring. And it provides this option, right? Monitoring enable. And then make enable function, that's just a library function that does a bunch of convenient stuff so that I don't have to say this is a true, right? Like this is a Boolean that defaults to true, or right? It just has all the defaults for what we expect an enable option to look like in Nix. And then once this is true, right, then we go into the config. This is what actually gets loaded into the NixOS configuration that imports this module. So we're saying if the enable option was true, then we're going to actually put the rest of the configuration. And then in the configuration, we're setting the configuration for other modules. So I'm saying CAdvisor, enable. Prometheus, it's enabled. And then also I can specify the port number and other settings for Prometheus, right? So this is really, really cool. It's going to set up each one of these things as a systemd service, which is really nice. And for what I would call like an appliance VM or even like an appliance physical device, this is awesome. You're like, I just want this device to run this one thing. I have a Raspberry Pi and it's just going to run Pi-hole. This is a great way to do it. You don't have to bring in Docker, and you still get isolation because each one of these packages is built in complete isolation from a dependency point of view, right? Not from a security point of view, but I'm assuming we're talking about Homelab here, so we're not talking about multi-tenant environments. So we don't care so much about that, but we do get isolation for dependencies, which is awesome because it means like you can have 4 different versions of Python installed, and one thing can even use Python 2 dot something, and the rest of your stuff doesn't have to care. So that's nice. But I use Docker a lot, and I had a lot of stuff already running in Docker, and also sometimes I'm running stuff that I don't necessarily trust with full root access, so I want to run it in Podman, right? We can do that very easily with Nix too. Oh, okay. I'm glad I included the zooms. So here's a zoom of some of that file, right? And we've got this directive virtualization.oci containers. And then inside that, I have a list of containers. And this syntax very, very closely matches the kinds of things that you would configure in a Docker run command or a Docker compose file. So I basically, to be honest, ChatGPT and other LLMs, not always great at Nix because there are not a ton of examples in their training data sets. But if you want to, say, give it a Docker compose file and say, translate this to Nix OCI containers, it's pretty good at that. So these are pretty easy to generate. And then you can run a container. And again, this container comes with all those conveniences of a Nix service. It gets a systemd unit. And then I get all of the systemd niceties, and conveniences, and tie-ins to observability and backups and all of that fun stuff. So it's pretty straightforward, right? We can make modules. Those modules can have options, and then those options can enable other modules and enable options in those other modules. All right, so here's an example of how I actually use this. I'm going to wrap up soon, and then we'll just have like some time for questions at the end, right? So I call raise your hand if you use Tailscale. Yes, that's a lot of people. Awesome. It's awesome, right? And it's free, so like, why not? And it's WireGuard under the hood, so if they do a rug pull, then you just have to deal with orchestrating WireGuard yourself, I guess. But I have a bunch of different physical locations connected with Tailnet subnet routers. I call them tailgates because it's a gateway to my Tailnet. This is the complete configuration for my main tailgate that provides access to my Homelab network, right? So I enabled Tailscale. I said use routing features. That's what's necessary for the Tailscale subnet routers. So they are there's a bunch of configuration that they put in their docs that you have to enable on normal Linux machines. Well, here it's just a single flag. And then, like I said, I've been running this thing since early 2024. So yeah, it's just been running untouched other than updates without issue, which is pretty cool. So what did I learn in 2 years of messing with all of this stuff? Well, when I set out, I had a really clear goal that I wanted to be able to run all of these services, and I wanted redundancy and resiliency and backups and high availability, and I wanted to use containers, and I wanted it to last for as long as possible so that I wouldn't have to touch it. And right, so I needed these things. I needed ingress, I needed DNS, I needed some kind of shared storage, I needed a monitoring and observability, and oops, I'm building a whole Kubernetes. So keep it simple, right? Don't build a whole Kubernetes. Don't do what I did. Which actually, Nix makes it really easy to do because you think you need all of these things. And then when you get down to it, you're like, oh, actually, everything just works like exactly the way that I want it. And I don't need all of these other catch-alls and I don't need to handle all of these scenarios that I didn't anticipate. So that brings me to my final point, which is like, when should you use a dedicated VM? When should you use Nix services inside a dedicated VM? When should you just use containers? I kind of hinted at this a little bit, right? But like, basically, I like to use dedicated VMs separate from the other VMs on a tenancy basis, right? So if I'm doing something for work, that's going to live in a separate VM than anything I'm doing for personal. And then within my personal life, I kind of separate my life up into a few different domains, let's say. And so I try to keep those things on separate VMs. Like I have my management domain. This is just for me to manage all of my infrastructure. And then I have my app domain. There's actually the stuff that I actually use, right? And so each one of those domains gets its own dedicated VMs. But then within one of those, I would have a VM for a purpose, like monitoring. And within the management domain, right, I would have a monitoring VM, monitors everything. And most of that stuff is running as Nix services because I don't touch it that often and I don't need the overhead of Docker. And then the actual app services that I'm changing all the time and like playing with new stuff, because someone today just showed me like why you know hosts, and like people are always telling me about cool new stuff that I want to try out. So I have a bunch of Dockerized hosts, some more ephemeral than others, that I can throw some of that stuff onto. And really the beauty of Nix, because all of this comes down to configuration that gets committed to code, is that if you solve a problem with Nix, whether it's in your shell, in your dot files, or in your complete system configuration, it's solved forever. So yes, NixOS is fun until it isn't. The rabbit holes are deep, the error messages are obscure, but the reward is solving problems once, which for my brain is just, yes, and then it makes you think about things differently when you realize that you only have to solve them once and then it's always going to work, right? You're less afraid to try things out. So more fun with Nix. I kind of hinted at some of these already, right? Home Manager is an awesome way to have my environment everywhere. There was a talk at Linuxfest Northwest. I think the title was something Nixbook, but basically the goal was to create like a thin client for a parent or someone not tech savvy that never needs to be touched and can be updated remotely. And with, right, so Nix is maybe not a great candidate for this, but it's definitely an interesting one. Another fun thing you can do is you can make a custom installer ISO. So like there's the NixOS installer ISO that you can just download, but you can also just build your own. You could put your SSH keys into it and enable SSH. And then you can SSH in, right? Just plug the USB stick into a machine, turn it on, and then go unattended, remote in, and complete the installation process, which is great if you want to surround with things that aren't supported by the visual installer like ZFS. And then there's another project within Nix that's called micro VMs, and this basically is like an alternative to QEMU. I'm not quite sure exactly how it works, but the idea is that you can have these kind of little namespace things that aren't quite LXCs or containers, but run Nix configurations. I need to check that out more. It looks cool. Yeah, okay, so questions, answers. And I also have, like, we can dive into my Homelab a little bit if we want to. Any questions?
Hi, I use Nix.
Okay,
DOS.
by the way.
Sorry?
By the way, I was making an arch joke. Sorry, go ahead.
You can hear me? Okay. How long did it take you, like, after using NixOS to start using Home Manager and for it to be functional? Was it a fairly quick setup or?
Yeah, for me, it was pretty quick. Although the first time I started using Home Manager, like you don't have to go all in with it, right? You can use it to manage some of your programs. And then for the others, if you already have your dot files, Home Manager has commands that will just copy files to the correct location, right? So it took me probably a month before I felt comfortable enough to translate my NeoVim config and like figure all of it out again with like, especially things like NeoVim and Tmux that have plugins. So you're like combining configuration with packages, and Nix has its own way of getting packages onto the system. Yeah, so I just ignored that and let NeoVim do things the NeoVim way, and like kind of kept playing with it until I had it working, and then I switched it over. Yeah. But yeah, you can start using Home Manager and just say, here's my dot file for this one, and then let NeoVim manage its own plugins, and that's fine. Any other questions? Yes. Microphone.
I just want to ask, what were you using as your like status page for your Homelab? Because I think I saw it earlier while you were like on the screen.
This is an iPad app called Termius. That's awesome.
Oh, okay, I see.
This is just SSH. It's just an SSH.
Okay, I see.
Client.
It's just boring. Okay.
Yeah. Other questions? Cool. Thanks for coming. Let's get dinner. There's some stickers in the front. Oh, and if you please could just scan, I promise these are not nefarious, but scan one of them so that my boss will keep paying for me to keep doing this. Thank you.